Hi, today's video is going to go through how to rationalize the denominator where you have a fraction with a third on the bottom. Rationalizing literally means that we want to have a number on the bottom, on the denominator of the fraction that is a rational number. A third is an irrational number. It is not something that can be written as a nice, neat fraction of one integer over the other. Therefore, it is an irrational number, and we want to make sure we have a rational number on the denominator of the denominator of the fraction. Which for this example means we need to have an integer on the bottom of the fraction rather than a third. So to do that, we use the fact that if we multiply a third by itself, we are squaring something that is a square root, and they cancel each other out, leaving us with just the number. We do root 3 times by root 3, we are left with 3. The thirds kind of cancel each other out. I did do a while back a thirds kind of basics video. So if you are unsure about how to multiply thirds together or add them or simplify them or any of those things, I will link the video in the description so that you can go and check that one out first and then come back and have a look at this rationalizing the denominator video, because this is kind of the more difficult part of thirds. So I am using the fact that root 3 times by root 3 makes 3, and I'm going to multiply the top and the bottom of my fraction by it to ensure that my fraction stays equivalent. So 2 times root 3 is just 2 root 3, and then root 3 times by root 3 gives us 3. The third, the roots kind of cancel each other out because we're multiplying it by itself. There is nothing else I can do there. There's no simplifying in the fraction that can happen because there's nothing that will divide into 2 and 3. So we leave that as it is, and that's it. The next one, I have 4 over 2 root 7. Now, if you wanted to, you can multiply the top and the bottom by 2 root 7. You can multiply it by that full term on the denominator of the fraction. However, that would mean that you have to do more simplifying at the end to make sure that your fraction is in its simplest form. So I'm only going to multiply by the root 7, which is still going to serve the purpose of cancelling out the third and leaving me with a rational number on the denominator of the fraction. So 4 times root 7 is 4 root 7. And then on the denominator I have, so don't forget that I have that 2, and I'm multiplying it by root 7, and another root 7 makes 7. So I have 2 times 7 on the bottom of that fraction. I'm not at this point even going to bother multiplying that together to make 14 because I'm going to have to simplify my fraction anyway. So that 2 on the bottom will cancel out some of that 4 because 4 is a multiple of 2, leaving me with 2 root 7 over 7 as my final answer with a bit of simplification over 7. Okay, again, there is a whole number, there is an integer on the bottom, on the denominator of my fraction. Therefore, I have successfully rationalized the denominator. An integer is a rational number. Okay, the next one, I have 6 plus root 2 over root 5. Don't panic because there is a longer expression on the top of the fraction. We're still doing the same thing. We are still multiplying the top and the bottom by the root 5 to cancel out the third part on the bottom. So that gives me root 5 on the bottom of my fraction. No, it doesn't. It gives me 5 on the bottom of my fraction. Don't forget that on the top, I am multiplying that root 5 by that full expression. I'm sure most of you will be able to do this in your head, but just to make it really clear, I am multiplying that root 5 by both things. So I'm putting a bracket in there to make that really, really clear. So I'm actually doing 6 times root 5, which is 6 root 5, plus root 5 times root 2 is root 10. They are both thirds, so I can multiply the numbers together. Gives me, and then it's over 5. Again, there's nothing I can simplify there. I would need to be able to divide the coefficient of the root 5 and the root 10 by 5, and I can't. 6 doesn't divide by 5. The 1 in front of the root 10 that I don't write, but it is there, also won't divide by 5, so I can leave it as it is. Now, those are the basic ones. Where we get more complicated is where we have something like this and you have a more complex expression on the denominator of the fraction. So I'm going to show you like the way that you want to do it, first of all, and explain why it is wrong. What you need to keep in mind all of the time is that if you are rationalising it, you are making the denominator an integer. It cannot have a third in it, otherwise it's still an irrational number. It's still, you haven't answered the question. Okay, so based on what we've done on the previous slide, most people's first instinct is to just multiply top and bottom by the third. Okay, so let's have a look what happens if we do that. We have 2 root 11 on the top, which is fine. But on the bottom, again, remember you're multiplying both parts of that expression, the 3 and the root 11, by root 11. So I get 3 times root 11 is 3 root 11, plus root 11 times root 11 is just 11. Hopefully you can see the issue there. I still have a third on the denominator of my fraction. It's not rationalised, it's still irrational. I haven't fixed the problem, okay? So just multiplying by the third top and bottom, in this case, it isn't going to work because we still have a third on the bottom because we've actually changed the part that was rational into an irrational number by multiplying it by the third. So it doesn't work, unfortunately, in this example, in this type of question. So we need to go back and try something different. The next mistake that I see a lot is multiplying just by the full expression, multiplying by the full denominator and doing 3, sorry, that's not what I wanted to do, and multiplying by 3 plus root 11 on the top and the bottom of your fraction. So again, let's see what happens there. So I'm doing 2 times 3 plus root 11, so 2 times 3 is 6, 2 times root 11 is 2 root 11. On the denominator, I'm going to write it out underneath and show you the full expansion. I'm doing 3 plus root 11 times by 3 plus root 11. So it actually makes a double bracket, and I need to expand that in the same way as I would with a quadratic expression. So I'm doing 3 times 3 is 9. 3 times root 11 is 3 root 11. Root 11 times 3 is 3 root 11 again. And then root 11 times root 11 is 11. If I simplify it, I have 9 plus 11 is 20, and I have plus 3 11 plus another 3 root 11 gives me 6 root 11. And that is my problem. So I still have a third on the denominator of my fraction, because when I've expanded it out, those middle terms still have a root 11 in them. So we still have an irrational number on the denominator of the fraction. So again, I still haven't solved the problem. I still haven't gotten rid of the third on the denominator. So I need to try something different. So this is what we actually have to do. I'm going to rub all this off and show you the real method. So in order to get rid of the third, we need to take advantage of the difference of two squares, which is what we're doing. We hopefully remember from when we were doing our quadratics and algebra and things, if we have x plus 3 multiplied by x minus 3, that gives us the difference of two squares. X squared times x, x times x is x squared. X times minus 3 is minus 3x. Plus 3 times x is plus 3x. And plus 3 times minus 3 is minus 9. The minus 3x and the plus 3x cancel each other out, leaving you with just x squared minus 9. Okay, that is the difference of two squares. It means that the middle terms, your x terms, are cancelling each other out, leaving you with just the x squared and the constant, but which are both square numbers. We are using that same idea when we are when we rationalise the denominator here. So I'm going to rub that off. We are going to multiply the top and the bottom of the fraction by 3 minus root 11. So I am changing the sign in the middle, and then I'm going to multiply top and bottom by that instead. So on the top now, I have 2 times 3 is 6, 2 times minus root 11 is minus 2 root 11. And on the bottom, I'm going to expand it out underneath, 3 plus root 11 times by 3 minus root 11. 3 times 3 is 9, 3 times minus root 11 is minus 3 root 11. Root 11 times 3 is plus 3 root 11. So hopefully you can see that's where it's going to cancel. And then root 11 times negative root 11 is negative 11. Okay, positive times a negative is negative. Root 11 times root 11 is just 11. Simplify where you can't, well, simplify it. And we get 9 minus 11 is negative 2. Minus 3 plus root 3. Sorry, minus 3 root 11 plus 3 root 11 cancel each other out. If you add them together, you would get 0. So they have gone, and now we just have negative 2 on the bottom of that fraction. Okay, lovely. Now it is rational. Now there is no thirds left on the denominator of the fraction. We have solved the problem. So the last thing to do is to check if there is any simplifying we can do within that fraction. So both the 6 and the 2 in front of the root 11 will both divide by negative 2 in this case. So we need to work that out. So 6 divided by negative 2 is negative 3. And then negative 2 root 11 divided by negative 2 is just 1, positive 1 root 11. Because a negative times by a negative gives you a positive answer. 2 divided by 2 is 1. And we've still got the root 11. And that's it. So that is our final answer. And there's no denominator because we've been able to simplify the fraction. But even before that, the denominator was a rational number. It was an integer. We'll do one last example just to hopefully reinforce that method. So this time we have 3 plus root 3 over 1 minus root 5. It's the denominator we're interested in, so we're going to multiply top and bottom by 1 plus root 5. So again, I've changed the sign in there, and that gives me, I'm going to write it out as brackets first, just so you can see what I'm doing. So on the top, I have the 3 plus root 2 multiplied by 1 plus root 5. On the bottom, I have 1 minus root 5 times by 1 plus root 5. I'm going to expand them both out, kind of out of the way. So up here, I'm expanding 3 plus root 2 and 1 plus root 5. So I've got 3 times 1 is 3. 3 times root 5 is 3 root 5. I have root 2 times 1 is just root 2. And I have root 2 times root 5 is root 10. Where am I getting root 2 from? It's root 3, isn't it? Oh, no. Oh, goodness. That is root 2 in there, which means this should be, I'm sorry, that should be root 3. I've changed the question. So yeah, I'm up to root 3 times 1 is root 3, and then root 3 times root 5 is root 15. There is no simplifying I can do there. There are no like terms. There is nothing I can add together, so I have to just leave it as it is. So the numerator of my fraction is 3 plus root 5 plus root 3 plus root 15. And that's it. That's as simple as it's going to get, unfortunately. The denominator, however, is going to become an integer. So I have 1 times 1 is 1, minus root 5 times 1 is minus root 5, 1 times root 5 is plus root 5, and then minus root 5 times positive root 5 makes negative 5. The roots cancelling each other out. We have minus root 5 plus root 5 makes 0 when you add them together. So they've gone, they've cancelled each other, leaving you with 1 minus 5 is negative 4, and that is our denominator. It might be negative, but it is rational, so we can leave it as it is. If you wanted to get rid of the negative on the denominator, you could kind of multiply through by negative 1 to get rid of the negative 4. It would mean switching all of the signs on the tops to negative. Yeah, so you could write it as negative 3 minus 3 root 5 minus root 3 minus root 15 over 4 if you really didn't want to have a negative on the bottom of the fraction. But if you wrote your answer like this, that is completely fine. It's correct. And you've done it. You have rationalised the denominator. You've made the numerator look awful with a really long expression that can't be simplified, but you have rationalised the denominator. It is no longer a third. And that's it. Okay, like I say, there is a thirds basics video if you really need to go back and check how to multiply things and add them and all of that stuff. I will link that in the description so you can go back and check that out. But otherwise, I hope this has helped. I hope it makes sense. And I hope you all have a lovely day. Thank you for watching.